Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about solving polynomials by division. There are two videos you're definitely going to want to watch as kind of prerequisites to this video, where you're either going to want to watch the videos or have a good understanding of these topics. And that's going to be our quadratic formula video, also synthetic division. So I'll link both of those at the top of this video. Be aware you're going to want to, if you don't understand either of those, then this is probably not going to make a lot of sense, because I'm going to kind of breeze through some of the stuff I explain in more detail in those videos. So solving polynomials by division is kind of like a last stop effort. When nothing else works, this is what we'll use. For example, when we can't use traditional factoring, when we can't use factor by grouping, if it's maybe a 4-term problem, you could try to use factor by grouping, but maybe you just don't get twins. When we can't use square root method. And the reason we couldn't use that is, for one thing, you'll notice with both of these, is they're not squares. These are cubed. When we can't use quadratic formula, again, these aren't quadratics, at least not yet. Hint, hint. We're going to try to get them to be quadratics. But when we can't use quadratic formula immediately, and we can't use completing the square, again, because these are not quadratics, they're not squares. When none of that will work, that's when we would do this. So when none of that would work, we would use division. So we're going to use something called synthetic division to try to make these into quadratics so that we can use the quadratic formula. That's kind of the goal here, to be able to solve this. So the first thing I want to point out is, again, why nothing else would work. So this is a cubic trinomial, so we can't traditionally factor it, we can't use square root, we can't use quadratic formula, none of that, okay? The first thing we want to do is lay out the number of solutions. So the number of solutions is always going to be equivalent to the degree of the polynomial. And what I mean by degree is just, what's your highest exponent? So in this case, notice our highest exponent is 3. It's a cubic trinomial, power of 3. So that means we are going to have 3 solutions. The next thing we want to try to find is a real rational solution. So you want to grab out your graphing calculator, and you want to go to your y equals. And we want to type in the equation that we have. So x cubed plus 3x minus 4. And then we want to go to the table. We want to find a whole number solution. So we know there's a total of 3 solutions, but in this case, there's only one real rational solution, and we want to find it. So we go second graph to look at our table. We can find a real rational solution by finding where y is a 0. Notice there's only, and you can scroll up and down a bit. You don't want to go too far. Once you start getting in the hundreds, you don't want to go past there, but notice there's only one place that has y as 0. That's a root. That tells me that the number paired with the 0, that's a solution. In this case, it's a whole number of 1, positive 1. So now that we know that a real rational solution is x equals positive 1. So that is one of our solutions. Remember, we have 3 of them. We know one of them is x equals 1. So we're going to use that information to try to turn this cubic trinomial into a quadratic trinomial so that we can solve that using the quadratic formula to find our other answers. Now, I know that sounds like a lot, so let's just take it step by step. First thing we're going to use is synthetic division. Remember, with our video with synthetic division, we set up our solution over here of positive 1. We then build this L. And then we say, okay, let's put our coefficients in a top line in this L. So our first coefficient, we don't see, but it's an understood 1. Our second coefficient, we also don't see. We have to be very careful here. So that's an x cubed. And so then the next degree down would be x squared, which we don't have. We don't have an x squared. It skips over that. We cannot just skip over that, though. When we're setting up synthetic division, remember, we have to have a placeholder of 0 there. If you don't have that placeholder of 0, your answer will be wrong. We've got that placeholder for x squared. Next would come just our plain x to the first. So that would be our coefficient of 3. And then lastly, we have our constant, which would be a -4. And then from here, we want to do our synthetic division process. So that means we bring down the first number, just 1. We then start our multiplication chain. 1 times 1 is a positive 1. We then combine down, so 0 plus 1 is 1. We continue this multiplication chain, so 1 times 1 again is just 1. 3 plus 1 is 4. And we do this one more time. So 1 times 4 is a positive 4. And now here's the fun part, okay? And this is a way you can double check to make sure you're doing your work correctly. So -4 plus 4, well, that's 0, right? You should always get a 0 when you get to the end. We have a remainder of 0, and that's what you want. If you do not have a remainder of 0, then we need to go back and see what happened. According to our synthetic division rules, we want to start back over here with this 1. And then instead of x cubed, we now start it with 1 down, which would be x squared. So we have 1x squared, or just x squared. We have a positive 1x, or just x. And then our constant is a positive 4. We have a remainder of 0, okay? So then we just bring down this equals 0. The only thing that's going to work at this point would be the quadratic formula. The quadratic formula is something you really want to have memorized. It's x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. In this case, our a would be an understood 1 out here. Our b would be, again, an understood 1, and our c would be a positive 4. So we're going to plug each of those values into our quadratic formula and solve. So we've got x equals -b, so that's going to be a -1, plus or minus square root of b squared, 1 squared, minus 4 times a, which is 1, times c, which is 4, all over 2 times a, which is 1. So remember, when we're solving our quadratic formula, we put in just this part first. So we just do our 1 squared. We're just simplifying to see what we get. Minus 4 times 1 times 4. Just the part. We do not include the square root in that. And we get a -15. Let's rewrite this reduced. So we have an x equals -1 plus or minus square root of -15. So that all simplified, -15 all over 2 times 1 is 2. Now at this point, we cannot take the square root of a -15. If you try to, your calculator is going to tell you, you can't do that. That's an imaginary number. So square root of -15 is really a square root of -1 times a square root of 15, right? This part simplifies to just I. We would want to check 15 to see if we could simplify that radical. If you need a little refresher on that, definitely watch my video on simplifying radicals. 15, the only factors that go into it are 5 and 3. We don't have any pairs there, so we can't simplify that radical any further. Taking that information, we know that we have x equals a -1 plus or minus I, and then we just have our square root of 15 all over 2. You would want to ask yourself, can I reduce -1/2 or this 1/2? And you cannot. So at that point, this would be our final answer along with the original answer that we found. So this x minus 1, that's also an answer. So we want to make sure we include that with our answer. It's x equals -1 plus or minus I square root of 15 all over 2 and 1. So you might be thinking, wait a minute, you told me right at the beginning that we have 3 solutions, but I only see 2 things written there. Well, this is really 2 in and of itself, because remember, this is -1 plus I square root of 15 over 2 and -1 minus I square root of 15 over 2. So don't forget that. That's actually 2 answers in one. So in total, we do have 3 solutions. Okay, let's do a second example. In this one, we have a cubic and it is a 4-term polynomial. Traditionally, you'd want to try factor by grouping. If you try factor by grouping, you're not going to end up with twins like we would need to. At that point, it would not work. So we would want to then move to solving this polynomial by division. Our number of solutions, remember we look at the exponent, and in this case our exponent is 3, so that tells me we are going to have 3 solutions. This is a cubic polynomial. Our real rational solution, well, let's grab out our graphing calculator and find it. Let's just type it in, x cubed plus 3x squared plus 2x minus 6. And we would want to go to our table to try to find that whole number solution, and look right there. So remember, when y is 0, that means that's a root or a solution. So the number that goes along with it is a solution. So in this case, it's also +1 again. So we're going to use that to try to turn this cubic function into a quadratic one, so that we can use quadratic formula to find the other 2 solutions. Our synthetic division starts with a 1 on the outside of the L. We start with our x cubed, and our coefficient is just a +1. Our next one down is an x squared. Okay, so far so good. We want to include that +3. Our next one down is an x to the first power, just as it should be, so we want to include that +2. And our last is our constant of -6, so we want to include that. So keep in mind here, we didn't have to have any 0 placeholders. We want to bring down our first coefficient of 1. We start this multiplication chain. So 1 times 1 is 1. 3 plus 1 is 4. All right, and then we start it again. So 1 times 4 is 4. And 2 plus 4 is 6. So we keep it going. 1 times 6 is 6, and -6 plus 6 is 0, which is good. Remember, when we're solving polynomials by division, we should always get a remainder of 0. So remember, when we use synthetic division, we jump back to the first coefficient, and then we take the first one down from the x cubed, which would be x squared. So we have 1x squared, right? And then we jump down to the 4, so just a 4x, and then our constant would be a +6 with a remainder of 0. We'll go ahead and bring down that equals 0. Now we're good to use quadratic formula. In this case, our a would be a +1, our b would be 4, and our c would be a 6. X equals -b, so -4 plus or minus the square root of 4 squared, b squared, minus 4 times a, 1, times c, 6, all over 2 times a, which is a 1. Remember, we always start by just simplifying what we have underneath the square root. So that would be 4 squared minus 4 times 1 times 6. And we get a -8. So we do x equals -4 plus or minus square root of -8 all over, and 2 times 1 is just a 2. Just like we had with that -15 over here, we can't take the square root of a negative number. We need to get rid of that negative number. And we do that, and again, I'll show it kind of here as well. So instead of -8, right, square root of -8, we can rewrite that as square root of negative 1, just kind of pulling that negative out, and square root of 8. So now you would want to ask yourself, the square root of negative 1, that's just going to become I. The square root of 8, though, that we can reduce. So the things that go into 8 are 4 and 2. We would break 4 down into 2 and 2. We have a pair of 2's with a 2 that's stuck. We've got, at this point, x equals negative 4 plus or minus. We have an I on the outside. We have a 2 on the outside, and we have a 2 that's stuck underneath the radical. So we would write that as 2i square root of 2 all over 2. Our final step will be to check, can we reduce this negative 4 over 2 and this 2 over 2? And we can reduce both of those. So you would want to do it. So I'm going to write our final answer over here as far as simplifying this. So we have x equals negative 4 divided by 2. Well, that would be negative 2. Then we have our plus or minus. 2 divided by 2 would be 1. So we just have 1i, or you could write that as just I. And then we still have that square root of 2. There is 2 of our answers, because remember, it's the positive version and the negative version, as well as that original answer, which we will include as well. So that x equals 1. Okay, let's look at one more example together. In this one, notice that this is a quartic degree. We have a quartic polynomial. This is a 5-term polynomial. In this case, we would definitely want to use division. When we determine our number of solutions, well, our highest exponent is 4, so that means we have 4 solutions. Now for our real rational solutions, you'll notice I put plural there because something interesting happens here with this one. So let's bring out our calculator. Let's type it in. I still have that other one. We'll clear it out. So we got 2x to the 4th power plus 7x cubed minus 2x squared minus 19x minus 12. That's a long one. And then move to your table. So second graph. I don't see any 0 yet. Let's keep looking. Okay, there's 1. Oh. Okay, there's 1, 0, which shows me a negative 1, a solution of negative 1. But then I have another 0, which shows me a solution of negative 3. So in this case, I have 2 real rational solutions. We would say that one of them is x equals negative 1. And the other one is x equals negative 3. This is going to be a special case where we're actually going to need to use synthetic division twice, and I'll show you how that looks. It's kind of cool. Let's go ahead and just pick one of the solutions. It doesn't matter which one you pick, but we'll just start with negative 1, and let's create our synthetic division table. So we start with a negative 1. We have our long L. Our first coefficient is 2, x to the 4th. And then we have our next coefficient is 7, that's our x cubed. And then we have a negative 2, that's our x squared. Then we have our negative 19, that's just our x. And then we have a negative 12 for a constant. So in here, we didn't skip any, so we didn't need any placeholders of 0. We'll go ahead and move through the synthetic division process. We bring this 2 down. And we'll start our multiplication chain. So negative 1 times 2 is negative 2. 7 minus 2 is 5. Negative 1 times 5 is negative 5. Negative 2 minus 5 is negative 7. Negative 1 times negative 7, that would be a positive 7. Negative 19 plus 7 would give us negative 12. Negative 1 times negative 12, well, that would give us positive 12. Now, negative 12 plus 12, that gives us 0, which is exactly what we want, a remainder of 0. So just to show you, I'm going to rewrite this with our x cubed. So our first term would be 2x cubed, and then we have a positive 5x squared. We have a negative 7x, and we have a minus 12 equals 0. Now, at this point, we've been using quadratic formula. However, notice we can't use quadratic formula. This is a cubic and it is a 4-term problem, so 2 different reasons why we cannot use quadratic formula. So we need to use this synthetic division process one more time so that we can get this down to a quadratic. And I'm going to do it using my other real rational solution of -3. So we're going to build a second box. We have to do this process twice. Remember, our first coefficient was 2x cubed, and then our 5, our -7, and then our -12. And now we can move through the process again. Bring our 2 down. We'll have our multiplication change. So -3 times 2 is -6. 5 minus 6 is -1. -3 times -1 would give me a +3. -7 plus 3 would give me a -4. And then -3 times -4, that would give me a +12. And -12 plus 12 is exactly what I want, a 0, a remainder of 0. So at this point, let's go back to this first coefficient. And notice we had an x cubed, so now we're going to move another one down. We're going to be an x squared now. So 2x squared minus 1x, or just minus x, minus 4 equals 0. Now we are ready for the quadratic formula. Our a would be 2, our b would be a -1, and our c would be a -4. So when I put that into my quadratic formula, I'm going to have a +1, right, -b plus or minus square root of -1 squared. You must have the parentheses there. It's so important. If you don't have those parentheses around that negative squared, your answer will be wrong. Okay, so -b squared minus 4 times a times c, all over 2 times a, and I forgot to add my little x equals. Let's start by reducing what we have underneath the radical. So bring out your graphing calculator. Let's do -1 squared with our parentheses minus 4 times 2 times -4. And we get a 33. Luckily this time I didn't get a negative. I got an x equals 1 plus or minus square root of 33 all over 2 times 2 is 4. Now I would want to check, can we reduce the square root of 33 anymore? The only thing that goes into 33 is 11 and 3, and neither one of those reduce any further. So no pairs, I can't simplify this radical anymore. I would then want to check, okay, can I reduce 1/4 and the understood 1 here, 1/4, and I cannot. So we have 2 of our final answers right here. 1 plus square root of 33 over 4 and 1 minus square root of 33 over 4. That is 2 answers. In addition, we have the 2 answers we found right at the beginning, and we're going to include those with our answers. So also we have x equals -1, and we also have x equals -3 for a total of 4 solutions. Okay, here's one for you guys to try. I will post the answers in the video description below. This has been Miss Smith's Math Tutorials.